Okay, let's dive right into this explainer. If you've ever found yourself wondering how pro audio software, like, say, Audacity, actually grabs sound from your mic and routes it to your speakers, you're in the right place. We're going to completely unpack the evolutionary journey of building a functional audio routing desktop app using Python right from scratch.
We're breaking this down into 6 distinct phases. We'll start with a basic command line script, build out a tkinter GUI, separate our inputs and outputs, wire up the actual audio routing and playback, debug the stream, and then finish up with some final polish and filtering.
All right, step 1, the basic command line script. Before we get ahead of ourselves with a fancy graphical interface, we have to make sure Python can actually see the audio hardware plugged into our machine. So our very first iteration is pretty bare bones. It just uses the sound device library, queries the system, and asks you to literally type a number into the console to pick a device. It works, sure, but it's really just a sketch at this point. Under the hood of that little text interface, the code is executing 3 basic steps. First, it queries your connected hardware using asnd.queryDevices. Second, it prints out a numbered list so you can actually read what's available. And third, it captures your numerical choice. And hey, it also validates that input so you don't accidentally type a letter and crash the whole script instantly.
Moving right along to Phase 2, building the tkinter GUI.
Let's be real. Typing numbers into a terminal just isn't intuitive for an audio engineer or a podcaster. We need to upgrade the chassis and give this app a proper face. The conceptual shift here is huge. We're moving from a rigid sequential command line flow, where you're stuck answering text prompts one by one, to a modern graphical user interface. Now we get dynamic elements like drop-down menus, and the flow becomes event-driven, meaning you can click around and select options in whatever order you want.
To make this happen, we import Python's tkinter library. This lets us define a main visual window and start dropping in modern UI elements. Specifically, we're using TTK combo boxes to display our audio devices in nice, neat dropdowns.
These are the exact building blocks that make our app feel like professional software. We initialize that main window with tk.tk, apply some sleek modern styling with theme tinter, use those combo boxes to tuck away our long list of devices, and finally, we wire up a physical select button to trigger our selection function. It's starting to look like a real app.
Which brings us to step 3, separating inputs and outputs.
So the app looks way better, but right now it's just dumping all your mics and speakers into one giant messy dropdown. We need to mirror real-world audio routing. Notice how the code evolves here to add 2 distinct combo boxes. One exclusively for your inputs, like a USB mic, and one for your outputs, like your studio monitors. We're establishing clear, distinct paths for the audio. We've even added a shiny new route and playback button. But if you were to click it right now, all it does is spit out a placeholder message in the console saying routing and playback functionality not implemented yet. Basically, we've built the visual endpoints, but we haven't actually run the digital cable between them.
Let's fix that in Part 4, routing and audio playback. It's time to replace that placeholder with the real deal and actively move audio from mic to speaker. To do this, we absolutely have to understand the audio callback. You can think of the callback as the constant, beating heart of our application. It's a special function automatically triggered by the sound device library hundreds of times a second, relentlessly catching new chunks of sound data as you speak.
But trying to keep that heartbeat going inside a graphical app requires some heavy lifting. We have to bring in Python's threading and queue modules. Why? Well, audio is a continuous, unstoppable stream of data. If we try to process all of that on the exact same thread as our GUI, the whole application window would completely freeze up. Threading lets us safely juggle the sound in the background, which is a total game changer for building responsive apps. Essentially, here is how we plug in that virtual cable. The callback reads chunks of incoming audio, tosses those chunks into a waiting line, which we call a thread-safe queue, and then a separate background loop continuously grabs data from that queue and feeds it straight to your speakers.
All right, step 5, debugging the audio stream.
As we all know, software development is almost never a straight line. When we fire up this complex new routing code alongside our GUI, we hit a brick wall. The script completely crashes. You try to click stop on the playback, and bam, you get this error. Name error, name window is not defined. Our progress grinds to a halt.
So what was the culprit? It all came down to the order of operations. Python reads code top to bottom, and our buttons were literally trying to reference the main window before we have even created it. Actually, scratch that. The fix is super simple. We just grab the initialization of our main window, that window equals tk.tk line, and move it to the very top of the script, way before any other components try to attach themselves to it. Problem solved.
And finally, Part 6, Final Polish and Filtering.
With the bug squashed and the audio routing perfectly from mic to speaker, it's time for that final coat of polish. We want this to feel totally professional, which means preventing the user from making impossible choices. Like previously, your input dropdown might have shown a pair of headphones that don't even have a microphone. To fix this, we use list comprehensions. The code now specifically checks if a device actually has input channels before it even shows up in the input dropdown, and it does the exact same logic for the outputs.
These last few refinements are what make the application truly robust. We're filtering in inputs and outputs by channel count. We set the combo box state to read-only so nobody can accidentally type gibberish into the menu. Plus, we've added dynamic checks so the app doesn't just crash if you boot it up and it happens to find 0 available input devices. It's totally user-friendly and essentially foolproof.
And there you have it. We just went all the way from a basic text prompt to a fully threaded graphical audio routing application. Now that you've got a solid grip on this iterative process of wiring a back-end audio engine to a graphical front end in Python, I have to ask, what incredible custom audio tool are you inspired to build next? Thanks for hanging out with us for this explainer, and happy coding.